Okay, so we start off with our third chapter, that is inverse trigonometry. Now, before we start, we need to understand a certain thing, that is, in trigonometry, what the functions are doing. The functions, that is, whenever we say sine theta, cos theta, tan theta, all these functions, they are basically doing what? When I am saying sine theta, it means in place of theta, there will be some value of angle I have to put, and sine theta is going to give me a value. So, what it actually is doing, it is it is taking an angle as an input and it is returning a value. Now, for different trigonometric functions, the values are different. Say, for example, sine theta gives me value between -1 to 1. Cos theta also same. For tan theta, it can give me value anywhere in between. So it can give me any value. So from minus infinity to infinity, it can give me any value in between. So similarly, the value which the value of the angle which the functions are taking, all these trigonometric functions are taking, they are the domain, they form the domain of that function, and the values which the functions are giving, they are the range of the function, which we already know from our class 11. So now what we are doing basically here is that I am writing x is equals to sine theta. So what does that mean? It means that theta is taking some value of angle and sine theta is giving me a value which is stored in x. So that means x is the output and theta is the input for this function. So now if I do something reverse in the sense, let me find or let me define a function which will do what? Which will take a value, take a numeric value, and it will return me the angle for which the sine of that angle gives me that value. So let me write it something like this. So if I write something like this, that means what? It means that this function, I haven't given any name to this function yet. So this function is doing what? It is taking some value x and it is returning back an angle for which sine theta is x. So therefore, we are calling this function as the inverse trigonometric function. So inverse trigonometric function means what? It is just the opposite function, opposite of what a trigonometric function is. So we are going to give a value as an input and it is going to give me back an angle. So in no way, generally the use of to the power -1 in exponent, we know that anything to the power -1 is 1 by that. So similarly, we can think that sine inverse x can be written as 1 by sine x, but that is definitely not so. Because this sine inverse notation, so let me just mark this. This sine inverse notation, this is an operator in the sense it is just a notation. So for no reason you should consider that sine inverse actually meaning that it is 1 by sine. Fine. So sine inverse is actually the opposite or inverse of the function sine. Right? So if this is clear, so next let us once again revise the domain and range of the trigonometric functions that we have done in our previous class. So first, if theta is between -π/2 and π/2, so once again let me just tell you one thing. In class 12 you have to adhere to the pi notation. there is no concept of degree notation anymore. So if you are still stuck with the degree notation, please ensure you shift into the pi notation, because now the whole of inverse trigonometry will be done in pi notation, so there won't be any angles like in degree notation involved. So if theta is between minus pi by 2 to pi by 2, that means if the theta is between minus 90 degree and plus 90 degree, I am just telling in degrees just in order to make you familiar with the angles once more. So just go back once, do ensure you revise the pi notation once again. So if theta lies between minus pi by 2 to pi by 2, then I know my sine theta will be lying between minus 1 to 1. This is something which we already know. Next, if theta lies between 0 to pi, that is from 0 to 180 degree, if theta lies between that, means if theta lies in this interval, then my cos theta will be lying between minus 1 to 1. This is also something we know. Now you may ask this one very simple question, why there are two different domains but the range is same? Well, obviously I know if we remember something called all sine tan cos, so not all the trigonometric functions give me similar values in the similar quadrant, in the same quadrant. So to get all possible values of a trigonometric function, for a different function I have a different set of angles. So for example, if I consider sine theta, if I would have taken the interval 0 to pi for sine theta, say if I would have taken this 0 to pi interval for sine theta, then both the intervals, say 0 to pi by 2 and pi by 2 to pi, that is from in the first quadrant as well as in the second quadrant. So just for your understanding, this is my 0, this is pi by 2, this is my pi, and this is okay, I don't need if I go the other way, then this is minus pi by 2. So now if I take this, so you see in the first quadrant sine is positive, in the second quadrant also sine is positive. So if I would have taken 0 to pi for sine theta, then I wouldn't have got any negative values. So where to get the negative values? Then definitely I have to go into the fourth quadrant to get the negative values. Similarly for cos, if I would have taken minus pi by 2 to pi by 2, now cos is positive both in the first quadrant as well as in the fourth quadrant. Then I wouldn't have got the negative values for cos if I would have taken minus pi by 2 to pi by 2. So therefore we have to understand that the domain is taken in such a way that it gives me all possible values, that is from minus 1 to 1, it gives me all possible values for sine or cos, whatever I am dealing with. So now if I go to the next one, that is if theta is between minus pi by 2 to pi by 2 but except minus pi by 2 and pi by 2. So the minus 90 and plus 90 degree, these two angles are left out, but all the values in between if I take, then I get tan theta lying between minus infinity to infinity. That means what? If the value of theta lies between minus pi by 2 to pi by 2, any angle between minus pi by 2 to pi by 2, then tan theta can give me values from minus infinity to plus infinity or any value in between. Again, in the same way, if I take theta between 0 to pi, means open 0 to open pi, means leaving 0 and pi, all the other values, then cot theta lies between minus infinity to infinity, right? So this much is clear. Next, if theta lies between closed 0 pi but leaving pi by 2, so this means that all the values between 0 to pi will be taken except the value pi by 2. So if I take all these values, then sec theta will lie between minus infinity to minus 1 and 1 to infinity. That means what? It can give me any value except the values between minus 1 and 1. So sec theta can never give me a value between minus 1 and 1. So if I try to write sec theta is equals to half, or sec theta is equals to 1 by root 3, or sec theta is equals to say 1 by root 2, all these values are not possible because sec theta can never give this value. Sec theta always gives me a value which is less than minus 1 or greater than 1, including minus 1 and 1, but never between minus 1 and 1. Again, and obviously why we are leaving out pi by 2, because sec pi by 2 is undefined, because we know cos pi by 2 is 0. So if cos pi by 2 is 0, so sec pi by 2 is undefined. So therefore we have to leave pi by 2. Similarly, if I take the interval minus pi by 2 to pi by 2, leaving the value 0. So all values between minus pi by 2 to pi by 2 except the point 0. Then cosec theta also does the same. Cosec theta also lies between, cosec theta gives me all the values except between minus 1 and 1. So this were the domain and range for my normal trigonometric functions which we have studied in our previous class in the sense previous year. Now let us understand this. Now whatever is the domain for the trigonometric function, that becomes the range for the inverse trigonometric function, and similarly whatever is the range for the trigonometric function becomes the domain for the inverse trigonometric function, because that is how the function is defined. In the inverse trigonometric function, what we are trying to do, we are trying to put the value and we are trying to get back the angle. So if I try to write the domain and range for the inverse trigonometric function, what happens? Exactly, it changes. It just swaps from the domain side to the range side. So now see, we are just going through this once again. So now if x belongs to minus 1 to 1, that means if x is taken from the closed interval minus 1 to 1, that means any value between minus 1 to 1, including minus 1 to 1, then sine inverse x lies between minus pi by 2 to pi by 2. That means what? If x is any value taken between minus 1 to 1, then sine inverse x, which is basically an angle which lies between minus pi by 2 to pi by 2. Then if x lies between minus 1 to 1, again cos inverse x will lie between 0 to pi. If x is in any real number, then tan inverse x lies between open minus pi by 2 to pi by 2. So we understand this once again, that tan inverse x can never give you a value pi by 2, because tan inverse x, tan theta for tan pi by 2 doesn't exist. That is why tan inverse x will never give you a value minus pi by 2 or pi by 2. Then again, if x is any real number, then cot inverse x lies between open 0 to pi. That means cot inverse x will give you any angle between 0 to pi, but never 0 or never pi. Then again, if I take x, which is any real number except between minus 1 and 1, then sec inverse x will give me a value between 0 to pi, but at the same point of time it will never give me a value pi by 2. And similarly the same for cosec inverse x. So once we understand this, these values are called the principal values. Why they are called principal values? Because you can definitely ask me one good question, that if I take any value of x, say for example half. So now sine 30 degree, that is sine pi by 6, is half. We know this. But at the same point of time, sine 150 degree is also half, for sure. But this is something we need to understand, that Sine inverse x, the function gives me a value only between minus pi by 2 to pi by 2. So any angle in that range is called a principal value. So now let us move to an example. Let us take one example and understand the situation. So let me take this. Let me take sine theta is equals to root 3 by 2. Now the moment we take this, sine theta is equals to root 3 by 2, we know we can write it theta as sine inverse root 3 by 2. Obviously sine going on the other side of the equation, it becomes sine inverse. So theta is equals to sine inverse root 3 by 2. So sine inverse is doing what? Sine inverse is going to give me that angle for which sine theta is root 3 by 2. So now understand this very carefully. Now if theta is pi by 3 means 60 degree. If theta is pi by 3, or 2 pi by 3 means 120 degree. So if theta is either pi by 3 or 2 pi by 3, for both the values of theta, sine theta is root 3 by 2. Obviously you can check, because sine pi by 3, that is sine 60, is directly root 3 by 2, and if sine 120 degree, I can write it as 90 plus 30, so it becomes cos 30, and it is also root 3 by 2. But we need to understand the idea of principal value. So we are not much bothered about any value. So this is not the case of general solution. This is obviously the particular solution. This is the principal value that we are trying to find out. So 2 pi by 3 doesn't lie between minus pi by 2 and pi by 2. So therefore the principal value will be obviously pi by 3. So this is something we have to understand. So the inverse trigonometric function, they deal with only the principal values. So in the question, if you are not mentioned principal value, if quote unquote this word is not mentioned principal value, but if the question is a question of inverse trigonometry, be sure that you are dealing with principal values. So inverse trigonometric function doesn't give any other value other than the principal values. Okay, let us understand by taking another example. So now let us consider this. Cos theta is equals to minus 1 by root 2. Now cos theta is minus 1 by root 2. So now if you have your class 11 trigonometry done right, then you can see that for theta is equals to 3 pi by 4 and theta is equals to 5 pi by 4. For these two values, cos theta is minus 1 by root 2. Now what is 3 pi by 4? 3 pi by 4 means, for pi by 4 means 45 degree. 3 pi by 4 means 135 degree. So if you write cos of 135 degree, that you can write as cos of 90 plus 45 degree, which becomes sine 45 degree, minus sine 45 degree, and that is minus 1 by root 2. And again 5 pi by 4, that is 180 plus 45 degree. So cos of 180 plus theta, that becomes minus cos theta. So minus cos 45, that is also minus 1 by root 2. So now in both these cases, cos gives me minus 1 by root 2. Right? So let me just do this once again. 3 pi by 4 lies in the second quadrant. In second quadrant, cos is negative. Again, in the third quadrant, cos is negative. But we have to understand this. 0 and pi, these two values are here. So for the principal value of cos, obviously I have to take that angle which lies between 0 to pi. So I can see 3 pi by 4 lies between 0 to pi, but not 5 pi by 4. So therefore my principal value will be 3 pi by 4. So just understand the idea of principal value. Principal value means I have to stick to that particular range of the trigonometric function. So the inverse trigonometric function. Next, now let us try understanding few properties. Now there are several properties. We are going to deal with all the properties. We are not dealing with all the properties in one class. We are dealing with them in different classes. So first class will be the basic properties, and then in the second class, in the subsequent class, we will be dealing with the other higher properties of inverse trigonometric functions. So now let us understand this. Let us take a triangle. Now we already know, if I have an angle designated, then the bounding side on which the angle lies is the base, the opposite side to the angle is the perpendicular, and the largest side is the hypotenuse. Obviously this is a right angled triangle. Now I know that sine theta is perpendicular by hypotenuse. This is something we already know. So now I can write this, that theta is equals to sine inverse p by h. Means just changing sine from sine to sine inverse, taking sine on the other side. Then again I can write cos theta is equals to b by h, right? If I can write cos theta is equals to b by h, then again I can write theta is equals to cos inverse b by h. So see, understand this, the same angle theta can be represented as sine inverse p by h as well as cos inverse b by h. So therefore I can write this. Understand how we can write this? The same angle theta can be represented by sine inverse p by h, similarly cos inverse b by h. Now rest all follows from here, because tan inverse, if tan theta can be written as p by b, so theta can be written as tan inverse p by b. Again, cot theta is b by p, so theta can be written as cot inverse b by p. But these are all representing the same angle, so therefore I can write this chain as sine inverse p by h is equals to cos inverse b by h equals to tan inverse p by b, and so on. Fine. So this is the first property. So now let us take an example and understand the first property. Say I have this, cos inverse 7 by 25 is equals to theta. So there is some angle theta, I don't know what that angle is, but the value of the angle is given to be cos inverse 7 by 25. Now understand this once again. Cos inverse is a function which represents angle. So therefore cos inverse 7 by 25 is representing some angle. Which angle I don't know, but some angle. Now if this is so, from the previous property, just let us go back once. Okay, let us go back once. So when I am writing cos inverse something, then I can always consider that something in the form of b by h. I can always consider whatever written inside cos inverse as base by hypotenuse. So let us go back to the example. So whenever I have cos inverse 7 by 25, I can consider 7 as the base and 25 as the hypotenuse. So if so, I can definitely think of this triangle where 7 is the base, 25 is the hypotenuse. I think this is pretty clear. This is exactly how you used to do when you started doing your trigonometry, the basics of trigonometry, when you were asked to find the value of cos theta, tan theta, when the value of sin theta was given. So similarly, here if cos inverse 7 by 25 is theta, that is, this is given, then definitely once I have considered the triangle, then I can find what is the perpendicular. Then the perpendicular is 24. Do your Pythagoras theorem, you will find it. So once we have found it, then definitely I can write theta as, instead of cos inverse 7 by 25, just see, can I not write it as sine inverse 24 by 25? Because I know sine inverse perpendicular by hypotenuse. So I can exactly write it something like this. So theta can be written as sine inverse 24 by 25, or in case of tan, then I can write tan inverse 24 by 7, that is perpendicular by base, and so on. So this was the first property. So any trigonometric inverse trigonometric function can be changed from one function to another function. So you can write sine inverse x as cos inverse something, or cos inverse x as sine inverse something, or tan inverse something. It's just that you have to draw that triangle, you have to place the values in its position. So if it is cos inverse, I have to place them in base and hypotenuse, and hence find the perpendicular, and from there I can change it into sine inverse, tan inverse, whatever I want. Now let us move to property 2. Property 2, now this is something which is pretty obvious for us to understand. Sine inverse x is giving me an angle, and sine of that angle if I take, so it is going to give me back x for sure. So this is very simple for us to understand. So let us understand. Say sine inverse half. So half, for which angle it gives me half? For 30 degree, that is pi by 6. So sine inverse half is pi by 6, obviously. But if I write sine of sine inverse half, then sine inverse half is pi by 6, and again sine of pi by 6 is half. So I get back the value half, right? Now there is one small condition we need to understand once again. What is the condition? That can I take any value of x? Can I take any value of x? So for example, if I want, can I write this? Say sine of don't just mind I am doing it with finger. So sine inverse 2. Can I write this? It's a question mark. Sine of sine inverse 2. So according to the property, it should give me the value 2, right? Because that's how the property is. Sine of sine inverse x is equals to x. So whatever the value of x is, it will come back. Now we have to understand this. Sine inverse 2, this statement is absolutely meaningless. Why? Because sine can never give me a value 2. Sine will never give me a value 2. So sine inverse 2 does not exist at all. So definitely this inside quantity does not exist. So sine of something which does not exist is not going to be 2 for sure. So therefore we need to understand that we can't take any value of x. Not just any random value of x that I think of. I can't take any random value of x. But I have to ensure that that x which I am taking must belong to the domain. Domain in the sense that set of value which is supposed to be taken for sine inverse. So I know for sine inverse x should be taken from -1 to 1. So therefore in case of sine inverse I must have that x between -1 to 1, otherwise this property is not going to hold. So this does not happen. So please understand that. So therefore x can't be any random value, but x has to be in that particular domain. So therefore this is very important to be mentioned, that x must lie in its domain. If it does not lie in its domain, then this property is not true. Therefore again we have another set of property, just the other opposite property, and I think I really need not explain this anymore. So sine inverse of sine theta is equals to theta, obviously true, but once again that theta must be in its domain. So theta has to be within that particular limit that is mentioned. So for sine, theta must be between minus pi by 2 to pi by 2. If I take say sine inverse sine 127 degree, say, so sine inverse sine of 127 degree is not going to be 127 degree. Why? Because 127 degree is not the domain of sine. For sine theta, the domain lies between minus 90 to 90. So therefore I cannot take theta as any value which is more than your given set of limits. Fine. So therefore these two properties hold only if my values are taken from where it should be taken, right? So let us go to the next property. Now we are going to do the solve the problems later, a little bit later. First let me go through the properties. So property number 3 is this, which is very simple for us to understand. Sine inverse of minus x is minus sine inverse x. So we already know this is from our basic trigonometry, that sine, let me just go through this. We know sine of minus theta, that is equals to minus sine theta. We already know that this happens. So similarly it is happening for sine inverse also. For sine inverse of minus x is minus sine inverse x. So as simple as that. Then again, next one, cos inverse minus x is pi minus cos inverse x. So now let us understand this. So this, I know if I write cos of minus theta, now does this give me minus cos theta? I think if you remember, for cos, minus sign is absorbed. Cos eats up the minus sign. So the minus sign doesn't come out. So this actually becomes cos theta. But if I do this, if I do cos pi minus theta, if I do this, if I do cos of pi minus theta, then what happens? Cos of 180 minus theta. Cos of 180 minus theta, that means it is in the second quadrant. Now pi is a even multiple of pi by 2, so cos remains cos, but in the second quadrant cos is negative, so therefore it becomes minus cos theta. So now if you understand this, so understand once again. So if I take this cos on the other side, what happens? Then I have pi minus theta is equals to cos inverse minus cos theta, right? If I take this cos on the other side, it becomes cos inverse minus cos theta, right? Now let us call cos theta as x. If I call cos theta as x, then x becomes cos inverse. If cos theta is x, then theta becomes cos inverse x. So then in place of cos theta, if I write x, then what happens? So from here, hold on, let me just shift this. Okay. So from here, I can write pi minus, in place of theta I can write cos inverse x, that is equals to cos inverse minus x. So understand this. In the first line I have cos of pi minus theta, which is minus cos theta, we know this. So now if I take the cos on the other side, it becomes cos inverse. So I can write pi minus theta as cos inverse of minus cos theta, right? So if I can write this as cos inverse of minus cos theta, now considering cos theta as x, then theta becomes cos inverse x. So just replace that. So in place of theta I am writing cos inverse x, and in place of cos theta I am writing x. So that gives me my property number, means the second part of the property. If this is clear, if not clear, just try going back once and see it once more, then I am pretty sure you will be getting it. If this is clear, then I think rest of the properties are pretty simple, similar to understand. Let me just remove this. Okay. Now what we have, The next one is tan inverse minus x, that is minus tan inverse x. We know that sine, tan and cosec, they behave the same way. Cos, sec and cot, they behave the same way. So therefore rest of the properties are easy to follow. So for cos inverse, cot inverse and sec inverse, they will be similar, and for sine inverse, tan inverse and cosec inverse, they will be similar. Fine. And then obviously x being in its domain is something I think I really need not mention anymore. We have understood the idea that we definitely need to have the values in its given limits. If the values are not in its limits, then we have to do something to bring them back into their limits, and then we have to solve. Next, the last property for this class. Now this is something which is obvious. Cosec inverse x is equals to sine inverse 1 by x. It is obvious. Cosec inverse means hypotenuse by perpendicular, and in case of sine inverse it is perpendicular by hypotenuse. So whatever is inside cosec inverse, if I want to change it into sine inverse, I just need to make it reciprocal. So from the previous example, if I have sine inverse theta is equals to sine inverse 24 by 25, then I can write this as cosec inverse 25 by 24. I think it is clear. And so is the other two. Sec inverse x can be written as cos inverse 1 by x, and cot inverse x can be written as tan inverse 1 by x. Fine. And obviously x must be in its domain. Fine. So once we are done with this, let's move to the examples. Now let us solve few examples and understand all these properties together. So let us take the first example. Find the value of cos inverse cos of 13 pi by 6. Now again, this is a question which seems very simple. Cos inverse cos of 13 pi by 6. 13 pi by 6 is so answer should have been 13 pi by 6 obviously, because cos inverse cos theta is theta. But again we need to understand this 13 pi by 6. Now 13 pi by 6 is what? This 13 pi by 6 does not lie between 0 to pi, as I told you that cos inverse cos theta is equals to theta holds only when the theta is within its domain. If the theta is not within its domain, then I can't write cos inverse cos theta as theta. So now if theta is not within its domain, then I have to do something to bring it back to its domain, otherwise I won't be able to work. So let us concentrate on cos of 13 pi by 6. So let us just understand this cos of 13 pi by 6. So see, cos of 13 pi by 6. So what is 13 pi by 6? I can write this as cos of 2 pi plus pi by 6. 13 pi means 12 pi plus pi. So there is one step which is not written here, so there will be one step in between. So I can write this as cos of 12, oh my goodness, 12 pi plus pi by 6. See, I can write this or not. Cos of 13 pi by 6, I can write this. So 12 pi by 6, that becomes 2 pi plus pi by 6, I can write. So now if I can write this, then cos of 2 pi plus pi by 6. So what is cos of 2 pi plus theta? Now 2 pi means what? Again, what is 2 pi? 2 pi means you are taking a complete rotation and coming back. So 2 pi plus pi by 6 is in the first quadrant. So therefore 2 pi plus pi by 6 is actually cos pi by 6 only, nothing more than that. So now once I have written cos 13 pi by 6 as cos pi by 6, now you can see this pi by 6, now it lies in this range. This pi by 6, it lies in the required limit of the angle where it should be. So therefore, now I can say that cos inverse cos of 13 pi by 6, that is equals to cos inverse cos of pi by 6, and that is my answer, which is pi by 6. So I hope this clears the idea that what principal value means. We are bothered only with those value of the angles which lie in that range, which is for cos, which is 0 to pi, and for different trigonometric, for different inverse trigonometric functions, there are different ranges. So you have to remember the ranges very carefully. And obviously, now those who have flouted, now we are hearing that people are flouting the lockdown measures for coronavirus. So the same way, those who have flouted the trigonometry classes or have not taken the trigonometry classes seriously in previous year, for you people, class 12 is going to be a kind of mess, and also a little bit hell also, just because as we enter into the next part, that is calculus, trigonometry becomes almost everything. Means everything has trigonometry in it. So therefore, please go through all the formulas of trigonometry once again, because you will be requiring them at some point or the other. Because now once you are in class 12, trigonometry is a tool to be used. So you need not explain how the formula comes. You need not show the formula, but definitely you can use the formulas, because all the trigonometry formulas now become trivial for you. So nobody is going to ask you how this formula comes, but they will see if you have used the formula correctly or not. So now, as you have a good amount of time back home, whenever you are sitting with this chapter, whenever you start this chapter, please ensure, as a recapitulation, go through the properties or the formulas of trigonometry once again. And obviously, compound angles, multiple angles, submultiple angles, those are going to come a little bit later, so we are not bothered about that. But definitely all those angle properties means cos of pi plus theta, or say sine of pi minus theta, all these properties, which angles in second quadrant, angles in third quadrant, angles in fourth quadrant, all these kind of properties, please go through, because those are the basic properties which you require to start inverse trigonometric function. Okay, so let us move to the next problem. Problem number 2. Now this is a little bit bigger one, but once we understand the idea, then it becomes easy. So you have to find the value of this big thing that is given: tan inverse inside the bracket 2 sine bracket 2 cos inverse root 3 by 2. It looks pretty big, but definitely it's a very small problem. We have to understand how to solve this problem. So always remember, whenever you have problems like this, we solve inside out. Inside out means we start from inside and we move outside. So therefore, first thing we need to solve is cos inverse root 3 by 2. So what is cos inverse root 3 by 2? So we need to find that angle for which cos gives me root 3 by 2. So cos of which angle is root 3 by 2? It is cos 30 degree. But again, I am telling you, don't be into degree notation. So try to get used to the pi notation. So cos pi by 6 is your root 3 by 2. So therefore, cos inverse root 3 by 2 is pi by 6. So therefore, in the next line, I can write this. So cos inverse root 3 by 2 can be written as pi by 6. So now 2 into pi by 6, that becomes pi by 3. Fine. So now what is sine pi by 3? Sine pi by 3 is again root 3 by 2. So let me write that. So sine pi by 3 is root 3 by 2. So 2 into root 3 by 2 is root 3, and tan inverse root 3 is pi by 3, because we know tan 60 degree, that is tan pi by 3 is root 3. So therefore tan inverse root 3 is pi by 3. So looks big, but definitely it's a very simple problem. Okay, don't mind that box. Anyhow, number 3. Find the value of sine of cot inverse cos of tan inverse x. So same problem. So previously there were numbers given, now you don't have numbers, you have just x. So how to solve this? Once again, let me write this first. Sine of cot inverse cos of tan inverse x. Now just remember that tan inverse of something can always be considered as tan inverse of perpendicular by base. I told you. So if tan inverse x, that means x is your perpendicular and nothing in the denominator means 1 is the base. So in that case I can consider this triangle. 1 is the base, x is the perpendicular. This is something I can always think or imagine. So now if I can imagine this, then I can find what is the hypotenuse. So what will be my hypotenuse? My hypotenuse will be under root 1 plus x square. Just apply your Pythagoras theorem. This is what it comes. Your hypotenuse will become under root 1 plus x square. So now I know if tan inverse p by b can be written as cos inverse b by h. So what is b? 1. What is h? Root over of 1 plus x square. So I can write something like this. I can write it like this. So tan inverse x can be written as cos inverse 1 by root over of 1 plus x square. So I think this is clear, because your hypotenuse is root over of 1 plus x square. So it becomes base upon hypotenuse. So it can be written as cos inverse 1 by root over of 1 plus x square. Fine. So now cos of cos inverse becomes your 1 by 1 root over of 1 plus x square. So therefore in the next step I can write it directly like this. So cos of cos inverse x is x. So I can write it something like this. I hope this is clear. Now comes the part where we need to understand this. Now again I have cot inverse something. When I have cot inverse something, so cot inverse something means, again remember what is cot? Cot means base by perpendicular. So cot inverse something can be considered as base by perpendicular. So 1 is your base and root over of 1 plus x square is your perpendicular. So again I can consider another triangle, something like this. Just understand how it is happening. So cot inverse 1 by root over of 1 plus x square. In this case 1 is my base and root over of 1 plus x square is my perpendicular. So therefore I can consider the triangle like this. So in such a case, what will be the hypotenuse? So do your calculation and see. The hypotenuse is going to be root over of 2 plus x square. Your hypotenuse is going to become 2 plus x square under root 2 plus x square, because root over of 1 plus x square whole square is 1 plus x square and 1 square is 1. So if you add them, it becomes 2 plus x square and under root of that. So this is your hypotenuse. So therefore what do I need? I need sine inverse. So sine inverse is nothing but perpendicular by hypotenuse. So it can be written as root over of 1 plus x square by root over of 2 plus x square. So if I can write so, then I can write it something like this. Hope this is clear. So now we are already at the final stage of the problem. So sine of sine inverse becomes the whatever the thing inside. So my final answer is this, under root 1 plus x square by 2 plus x square. So it's nothing tricky. It's just that we need to consider the triangles. We need to consider the triangles to change the ratios, one inverse trigonometric ratio into the other. Now let us move to the next problem, number 4. Okay, this is a simple problem. Tan inverse 1 plus sine inverse minus half. So tan inverse 1 plus sine inverse minus half. So in the next line, I know sine inverse minus x is minus sine inverse x. So I can write like this. The minus comes out of sine inverse and it becomes minus. Now we just need to put the values. So what is tan inverse 1? Tan inverse 1 means, when does tan gives 1? On 45 degree, that is pi by 4. And sine inverse half, that is again 30 degree, that is pi by 6. So therefore I have this pi by 4 minus pi by 6, that is equals to pi by 12. So this is my answer. So simple. The idea is pretty simple. I think nothing much to explain here anyhow. Next, last problem, problem number 5. Again, almost similar problem, but just in order to make you understand the application. Tan inverse root 3 minus sec inverse minus 2. So tan inverse root 3 minus sec inverse minus 2. So let us first write this. Now understand this, sec inverse minus 2. So let me just write one step here. Oh my goodness. So I can write this as tan inverse minus 3. Tan inverse, root 3. Now minus of sec inverse minus 2. So let that minus be there. So I can write it here, pi minus sec inverse 2. Can I not write? Because sec inverse of minus 2 is pi minus sec inverse 2. That is the formula. So if I can write this, so I have just skipped this step. I have gone to the next step directly. So just to make you understand that sec inverse minus 2 can be written as pi minus sec inverse 2. So once I write this, I can write it something like this. So the minus multiplied, it becomes tan inverse root 3 minus pi plus sec inverse 2. Fine. I think this is clear. Now next step, now we need to put the values. Now tan inverse root 3. Tan inverse root 3 is pi by 3, 60 degree, pi by 3. And sec inverse 2. Sec inverse 2 is like cos inverse half. Now sec inverse 2 means cos inverse half. And when does cos give half? It gives half at pi by 3 once again. So therefore it becomes pi by 3 minus pi plus pi by 3 once again. So now if you just do your calculation, it becomes minus pi by 3. So this is your answer. So therefore in inverse trigonometry, it is I don't think it is that complicated though, like as you have started trigonometry previously. It's just that you have to keep in mind the principal values. You have to keep in mind that from which value to which value tan inverse can take, or means sine inverse, cos inverse, tan inverse all can take the value, and most importantly, which is the range of the angle in which they give the value. So that is very important. So just remember that will be more than enough. So, and most importantly, please ensure you go through all the formulas, particularly the angle formulas. For timing, go through the angle formulas. You don't have to go through the all formulas at a time. So as I'm telling you which formula to go through, do go through the formulas in that order. It will be easy for you to remember. So go through the angle formulas. Angle formulas means all the angle formulas in the quadrant. That is, what will be the value in the second quadrant, what will be the value in the third quadrant, and those and so on. So if you remember them, then definitely it will be easy for you to solve the problems. And also, if you can remember the formulas for compound angle, multiple angle, submultiple angle, it's very good. And we will be dealing with those problems a little bit later. Anyhow, so thank you. So let us meet once again on Friday, because as we are given the schedule, so Tuesdays and Fridays, so I will be posting the videos following this schedule only. So the next video will be posted coming Friday at the same point of time, whenever the time is given. Okay, thank you.